cuántas ya hay en la universidad para cooperar y si hay otras. Ajá.
La única cosa es que mañana, tarde, yo tengo una reunión en función de cooperación que
¿Y a qué hora?
a 14 horas.
Ah, porque es de 14 a las 16. Entonces, bueno. O si tú nos quieres dejar, al menos, porque lo que podemos hacer es que les compartimos la
Okay.
Entonces, si tienes slides que hablen de tu universidad.
Yo tengo que ver si yo,
a ver, ve,
si yo estoy
si...
con alguna cosa. Yo creo que hay algunos de Graftech que puedo hacer.
Okay. Sí, o alguna cosa, exacto, como para que se les quede. Bueno.
Ellos nos conocen bien.
Sí,
también.
Claro. Bueno, ustedes tienen mucho más, pero la idea es que, bueno, que esté, digamos, lo máximo posible de información.
Justamente como yo tenía visto que había la parte internacional después del museo,
sí,
que yo conozco,
claro,
yo aproveché para marcar la reunión.
No hay problema. Sí, bueno, continua francese. Oui, donc, pas de... oui,
non,
mais si...
Una mezcla.
Una mezcla.
Começa a falar ao idioma que está mais próximo, mais perto.
Tengo que... ¿Tu turno?
To turn on?
Aqui eu tenho um problema grave, porque eu começo
I put only 5
spots. E ele vem como idioma estrangeiro mais forte do que pelo fato de doutorado aqui já faz uns 15 anos, mas aí o francês vem muito forte. Eu tentar falar em inglês, falar em francês, falar em espanhol, falar em francês.
¿Tú conoces?
Je connais le problème. Je sais bien le problème.
Não, olha, é difícil. Tem que tipo assim, ó, não dá para ficar trocando de uma para outra. Tem que começar com uma e ir, porque senão vai misturando. Eu falei que uma vez o que vale. Finalmente que eu não falo nenhum.
No se marche pas.
Qu'est-ce qui ne marche pas?
No está mostrando nada.
No, yo lo quité porque primero quería abrir, si no, no veo.
Est-ce que tu peux m'aider là?
Si nos puedes ayudar, es que queremos presentar en los lados.
Vas a personar.
No, no quiero pegar
Sí,
eso
con
para...
esa. Vas a ver.
Por tab de 2, ¿tengo que apretarla?
Creo que tienes que apretar uno,
sí.
¿no?
Selector por
Nada
tab.
más que si aprietas ese y yo me
No,
voy.
para la... Muda solo.
Sí, ok. Entonces esta es la principal. Debe de haber otro.
Si no...
Pero ya proyectaron algo.
Sí, no me importa, lo cambiamos.
Cambiamos, sí.
Este es el switch. Y si presionas 4 o 3.
A ver, 3.
No, lo cambia, lo saca de allá.
Normalmente se podía, pero...
Sí, pero ¿dónde está conectado?
¿Qué cosa cambiamos?
Sí.
1, 2, 3, 4.
¿Cómo?
Tengo idea. Pero era... No llegué a ver a Cristian. No sé qué está. Es que
Hay que, bueno, en la pausa hay que ir por el contexto.
¿Cuál ponemos?
El del restaurante.
Ya lo tengo.
Ah, ya lo tengo. Ah, que le llevaste la persona los huevos. Es medio...
Como la contesta de ese tipo. De hecho, fue ella el que fue. Tengo una cosa que voy a extrañar ya después de todo el mundo me conoce. Sí, hasta Herbeta solo porque me dormí. No le...
Acá hay muchos folders. Eso habría que ver si a alguien le falta. Porque hay unos que acaban de llegar.
Falta aquí. No sé, es que es súper...
Por ejemplo, el Lourdes.
Ah, o sea, el registro.
Sí.
Oye, Bernadette.
I'm giving 1 minute to go.
Solo estoy buscando a...
Meu carregador, isso daí. Carregador. E tá aí ou peguei?
Sei não.
E tá no canto do Placido.
Esse aqui?
É.
Provavelmente não. Provavelmente só seja o menorzinho, não?
Ah, é?
Não sei.
Peraí, deixa eu ver se tá aqui.
Não, é esse aqui. É esse aqui.
Sí.
O menorzinho ali, Daniel.
No está. Además hay que entregar los diplomas, ¿no?
No, pero eso es al final. O sea, los stickers sí, pero los demás.
Apenas después.
Okay.
So I'm going to start smoothly to avoid overflowing on time. So this presentation will be done by myself, Genoveva Vargas, and by Placido Sousa. So this is a real French-Brazilian presentation. And what we're going to do is focus on data management problems, particularly focusing on no and new SQL systems. So this is about storage, this is about heterogeneous data, and this is about platforms that are considered to be able to deal with services with a lot of data, and eventually that with processes that are somehow greedy, computationally speaking. But anyway, we wanted to associate the presentation to smart cities, and from our point of view, what is interesting about data management with respect to smart cities is data. But what is particular about this context is that we can have, if the presentation moves, yes, a kind of cybernetics vision. Cybernetics is an idea, very old idea, from Norbert Wiener. And Norbert Wiener, among others, considered that it is possible to model complex systems. And in order to model such a system, you're going to consider it as a being, as an organization, and that where there will be processes and interaction through data. Okay, so we are going to adopt this kind of cybernetics vision, and we're going to consider that a smart city is a kind of living entity that where there are a lot of entities composing this complex entity, and that they exchange messages and particularly data. So the definition of cybernetics, just to close the vision about it, is that it is possible to have exploring regularly systems, their structures, their constraints, and their possibilities. And so that's somehow what we're doing when we want to control and observe a smart city. And from our point of view, the enabling element of smart cities are data. And we are going to focus on that by considering some challenges. And particularly these challenges will be associated to the VIS model that are used to represent the properties of big data. For those that do not know the VIS model, it is a way to say that in order to characterize big data, it is possible to associate several properties that are starting with V, so volume, variety, velocity, veracity, and a few properties that can be associated to data and particularly to big data. But in our presentation, we are going to focus on some states of data management. First of all, acquisition, then archiving, modeling, storing, retrieving, and exploiting. And from our point of view, these are the main tasks that have to be applied to big data management. And each of them has its complexity and is a research topic. So in order to deal with big data and with huge volumes of data, it is important, of course, to consider the most representative or the most evident property of data, which is volume. So we are going to deal with collections, very big collections, that will be represented by between peta and iota bytes of information. We are going to deal with heterogeneity, and when we talk about heterogeneity and we want to do data management, it is important to consider the architecture associated to this process. And what we're going to consider is that concerning architecture, we're going to go from centralized storage supports into much more complex architectures where it is possible to have distributed storage supports available through the notion of service, and that will be managed by infrastructures like the cloud, okay? So this will be the architecture aspect, and what the challenge is to acquire somehow this data and then try to storage them in a way that eventually we will be able to process them efficiently. Efficiently, considering, of course, the storage resources, but also considering the computing resources. So we're going to, the objective of the game is to try to balance the use of computing support, of storage support, and of memory support in order to try to use this data in the process that I described before. The challenges are related, as the previous talk was discussing. Of course, there are a lot of formats, and we do not want to avoid having different formats. We want to accept the fact that there are different formats and that we cannot do nothing about it. We have to deal with this. The second aspect is, of course, sizes. Then, which kind of storage supports are going to be adapted to deal with these sizes? Today, as you can know, storage supports goes from the local disk, but the local disks have different characteristics, physical characteristics, and it can be, storage support can be virtual, and it can be seen as a complex service where we can ask for space, and then we can store our data. We store the data in order to use the data. So the important aspect also is to have well-adapted delivery mechanisms in order to retrieve parts of the data or transform and then be able to use those data. Concerning, well, when somebody does data management, there are two important elements to consider. First of all, computer science is about modeling. So it is important to model the data. And as I said, data are diverse, so it is important to consider that they can be represented under different data models. And in the current historical moment, we have a lot of data models that can be used in order to represent our data. What is important to say is that until 5 years ago, more or less, we used to define the model and then oblige the data to cope to the model. When we're talking about huge volumes of data, this is no longer possible. Because, of course, the reasons are like time to market for building databases. If you use a structured approach in order to model your data, the time to market in order to produce a useful database will be long, because you have to understand the meaning world with respect to the data, the way the data will be used, and then if you, for instance, use the relational model, you have to define a well-structured with good properties schema that will be used in order to structure the data. When you're talking about a lot of volume, and particularly about the velocity of the data, this is no longer possible because new data are coming, they are diverse, so your schema is old every minute, okay? So the idea is that rather have different possibilities of data modeling that will respect the characteristics, original characteristics of the data, and rather concentrate on the way this data will be managed. How are we going to use them? How are we going to archive them? How are we going to analyze them in a way that we profit from their original structure and provide the good algorithms in order to exploit them and transform them and use them. Okay, so first element of data management. The second element of data management are properties. When you use data, you want a certain quality in the way you perform your data management. And this is associated to non-functional properties. Normally, and particularly when you have big data collections, you are going to share the data. And you are not expecting one or two people using the data. You are expecting a lot of users. This is big data. It's not only about the volume of the data you're dealing with, it is about the number of consumers that are going to use the data. And sometimes this use is continuous. So it is important, for instance, to consider well-adapted concurrency strategies in order that all these people can exploit the data with a certain quality. The second aspect is consistency. Today, we are in a kind of postmodern world. Consistency before was a very strict property. You want your data to be absolute consistent with respect to the mini world they are representing. Today, the mini world is very complex. So what is true for one part of the mini world, it's not true for the other part of the mini world. So you have to have a spectrum of consistency properties that can adapt to different uses. So another important non-functional property that you have to deal with in a kind of tuning manner. And finally, atomicity. Atomicity is related to fault tolerance. Of course, we know that the more complex we have a system, it is very probably that we will have faults. So the objective is to have strategies that can deal with kind of levels of atomicity. I want my operations to be kind of consistent. So that I want everything or nothing to be done in order to acquire a certain level of functional quality. Again, this kind of atomicity depends on the way I'm using the resource, in this case, the data. If I am collaborating with people, I would like to see the process in which these data are being used in order to achieve a final task. So I want to have kind of the reads between during the process of modification. And in other cases, if I'm a bank, now I have more strict expectations, and I want to have a global and a clear view of the state of my money with respect to the operations I'm dealing with. So in a kind of modern view of data management, these aspects together with data modeling aspects will be used in order to provide a kind of ad hoc solution for data management depending on the type of data and depending on the type of use that I will be associating to data. So let's build a system that can do that. The idea with respect to data management is that what we can learn from previous works is that it is possible to identify at least 4 levels of data management, which are the following. First of all, there's the acquisition problem. So we are supposing that we have a complex or not complex infrastructure, hardware infrastructure, that will help us to collect the data. And the data can come as data, but they can also come as signals. Yesterday, our colleagues were talking about sensors, and they said, well, in fact, we retrieve a signal, and then we represent it the way we need. So we can expect that, or we can expect data, for instance, coming from social networks. The next part is, once we have the data in general, and particularly when there's a lot of data, we need to archive it, to store them somewhere. So there are the storage aspect of the management is another important level. Then once we have data stored in some persistency support, we have to have the good access services in order to retrieve the data from either memory or from the disk. And finally, we will have other levels in order to exploit this data. In the era of services, this can be considered, every element, every layer of the architecture can be considered composed by different services. Each service will be adapted to the hardware. If we are talking for the first layer, it is related to. So I will not acquire data in the same way coming from a sensor that coming from my iPhone or coming from other device or from people. Okay. Then similar from storage supports, it's not the same to have a flash memory or to have a classic storage support. So these services will be adapted to the physical characteristics of the storage support in order to be able to retrieve them efficiently. It's the same for the access services. I need well-structured indexes that can couple with the way the data are stored, always to try to retrieve them in an efficient manner, and so on with the other layers. These layers, there are 2 additional ones that have emerged because we want to exploit the data. But when we have to deal with a lot of data, it is not possible to watch them in a sequential manner. We have to have aggregated views of the data so that we can exploit it. So there are additional services that will be coupled with the rest of the architecture in order to be able to exploit the data. So if we keep in mind this architecture, in fact, this corresponds to the architecture of a data management system, service-oriented data management system, okay? It's been proposed 5 or 6 years ago, and it is the way we are supposed to organize a data management service in order to deal with huge volumes of data. Now, if we go further on the data management problems, once we consider this architecture, in fact, we have 4 problems to deal with. The first problem is the easiest and the most evident one, and this corresponds to the data models. If we are going to use the data models, in particular in this presentation, to refer to the way we are going to build databases, okay? So, data modeling is very, very old. In the 60s, there was a big, I mean, we can consider that it is the beginning of a philosophy that is related with the fact that we can separate the representation of data with respect to the operations related to this representation. And this means that it is important to have the structures that will be used in order to represent the data and the associated functions that will deal with these structures in a performant manner. You are very young, but this was first proposed by the specification of a language called COBOL. In COBOL, it was possible to represent the data and have associated functions. And with this philosophy, there was a whole database management theory that was developed some years later. So if we want to summarize the philosophy of this representation, the idea, as I said before, was to have a knowledge representation of data where the most representative model associated to them was the relational model, where we have the basic structure of the relational model is the notion of relation. And the operations related to this structure are insert, delete, well, and then the algebra operations like selection, projection, etc. The 5 main operations. It was very good, but the problem when you define a model is the expressivity of the model. The relational model is useful, but not when we have complex structures to represent. And there were, during the history, evolutions in order to try to have a very expressive representation of data with the benefits of having a mathematical representation with well-defined operations. And we have had the object-oriented models and some other models until we have arrived to almost today, where new systems are appearing with new models that are organized under the notion of NoSQL data models. When you are going to model data anyway, imagine that we didn't know about relational or whatever. What is important in the exercise of modeling data is that we have to balance 3 elements. First of all, have the perfect data structures in order to represent the data. Then we need expressivity, and then we need performance. And that's what we learn in the first courses of computer science. You have to deal with a good data structure, have the operations, and then try to make these operations performant. Otherwise, it is not interesting to have a solution. Today, we have, in the vision of data modeling, we have 3 basic structures that have been used to define the different models. First of all, the most simplest structure that we can have is the notion, not of relational, it was applied to relational model, but is the notion of a tuple. So we have attributes typed attributes, a series of typed attributes. And the types are very important because they will define the type of operations that we are going to apply to the data. And we can have simple tuple models where the attributes are of atomic types, or we can have more complex one where you accept that the attributes can be tuples themselves. And then you have a much more complex model. And this is useful because you can represent data coming from the network as tuples. And you can also represent data coming from your iPhones as tuples, and you can also represent data coming from your applications as tuples. For instance, the posts of Facebook are tuples, okay? Then there was a web, and the web is based on the notion of document. So another way of modeling data is the notion of document, where there is a semi-structure element that can have other nested values in order to be able to represent complex documents. And the particularity of this is that the schema is not fixed, that you can have or not some of the elements of the document. And this can be interesting when the structures of the data are not fixed. And then there's a notion of a more complex thing, which is expressed as extensible records. So a record, everybody knows what it is, and the idea is that for each attribute of the record, you will be able to have histories of the values of each element of the record, and the record has also columns, and you can also have different versions of the columns. Okay, so it's a kind of cube. A hypercube. And this is interesting because there are a lot of applications that need to aggregate data, and having by per se data represented in an aggregate way can be helpful when you want to have data analytics. So using these three elements today, we can consider that we have different models and systems that deal with these models. So the most simple way of having data model related to a store is the key value model. So I have an identifier and then a value that can be a blob, that can be a scalar or whatever. And this structure will be adapted for expressing this kind of data. Then we have documents, then we have extensible records per se, and there are other systems that consider that the graph-oriented representations are well adapted for dealing with the data. And the most common example of graphs is our connections in social networks. So this kind of structure can be helpful to represent this information, and for those that wanted to sales, recommendation systems, and so on, consider that these graphs can be exploited in order to sell us things with respect to our profiles. And of course, there will be always there, the relational will be always there because of mathematical reasons, but also because of economical reasons. There's a lot of systems and a lot of applications built on top of relational systems. So people do not want to start their applications from scratch. So they want to keep these relational solutions and then try to combine them eventually with other ones. What I said before talking about the models is that it is of course important to be interested on the type of structure, but it is also important to know what we can do with these structures. And what we can do is every time that we have our data, we want to retrieve them. So what we are interested in is in the APIs that a system should provide in order to deal with collections represented in the different models, and then what can we expect about the system, okay? So normally we will have the APIs with the basic read and write operations, and eventually with well-adapted lookups based on specific indexing structures. And then we will have an important element related to the second aspect that I described concerning data management, which are the properties that I can expect once I have a collection with these structures. So for instance, in the key value stores, it is important to see how data are replicated in order to ensure availability, whether they are versioned or not, which type of locking they provide in order to ensure concurrency, which type of transaction models they provide, and what kind of organization that I can expect related to my data in order to be able to retrieve them. I'm not going to go through the details of the systems, but every time I describe data model, I have a list of existing systems that use this type of data model. For instance, in this case, Redis and Voldemort are one of the most prominent systems, and the oldest one, those that deal with distributed systems should know the memcached model, and the memcached model is implemented by Membase. How could complex data look like when using this type of solution? Well, if you consider a Facebook page, what you will have is different elements of the Facebook page that are related to an identifier. The idea, of course, is the key will be the identifier of the element as an object ID. And the value, well, it depends on what I'm storing. I could have values like these, which can be documents. I could have values like these that could be images, and each of the image represented by an ID. And then I can have, of course, related query languages that can help me to get the IDs, logic or physical IDs of the elements, and then retrieve them from a database. If I have documents, it is always the same philosophy. I will have well-adapted indexes in order to deal with my documents. I will have some operations related to the way I'm going to manage the documents, my API, and of course, you have understand, because you are expert computer scientists, is that depending on the representation structure that I'm going to use, I will be able to write less or more complex queries. Okay, when we have key value models, the queries are reduced to lookups with respect to the ID of the element. When I'm dealing with documents, I already have structures. So it is possible to write more complex queries related to the structure of the documents. And of course, I didn't mention that, but when you are dealing with this type of operations, are in general computationally costly. So the idea with these stores is that they want to associate a programming paradigm to the definition of these operations in order to be able to exploit huge collections of documents. So in general, the systems that use these type of structures privilege the MapReduce programming model, because they suppose that the system will be installed in a cluster, and that it is possible through parallelization to have more efficient operations related to queries. So those that are using NoSQL. For instance, MongoDB is a prominent representation of the document stores. This looks kind of less complex than the previous one. What I will have is an identification of the document, and then the document where I can access to the different structures of the document through navigational operations. Again, with extensible records, I will not stop on the repeating the same things as the previous one. What is important to consider about this is that these extensible records are well adapted for analytics and aggregations. And one of the most famous ones is HBase and Cassandra from Facebook. Now, of course, the relational arena have to respond to the new NoSQL systems and models coming in the market. And the idea was to see which were the pitfalls of the systems in order to try to be normally what they have been accused of is to be less performant with respect to the other solutions when they have to deal with a lot of data. So the idea was to try to see how to reorganize, particularly the architecture, in order to make them more efficient. And there's a bunch of solutions called the scalable relational solutions, and normally known as new SQL solutions, that are trying to see how to provide performance with a lot of data, but with the properties that we have normally in a relational solution. These properties are related to transactions, and the idea is that we are going to have the transactional model normally related to relational systems. We'll also have the declarative language that some of us are used to use, that is SQL, and instead of having to write our own operations in a new one, parallel is not new, but in a particular programming paradigm in order to provide data management solutions. There are some interesting ones. For instance, MySQL-C, which is used in a lot of exercises in Facebook. So this means that MySQL deployed on clusters can be used in order to deal with huge amounts of data in good manners. The only comment that people say about using these kind of systems is that tuning is an important process to go through. Okay, so it is important to couple the physical architecture of your cluster with the system in order to ensure that it will deal in a performant manner with your data. But if you have used NoSQL solutions, you know that this is also the case in NoSQL solutions. So I'm going to skip this, and then the other, in order to summarize, of course, the data model is important, particularly when we have new data models related to data management. But there are other non-functional properties that must be considered and that will determine the type of expectation that we can have to associated systems. Another important thing to bear in mind is that normally these kind of solutions are well adapted to applications that need to do a lot of read and writes. Okay? If you want to join, correlate, etc., then you have to think more thoroughly about the type of solution, data management solution that you need. But if you want to read and write, you can be sure that these type of systems are for you. Okay? And then, of course, there are other elements to be considered. For instance, concerning querying. If some of the solutions related to new data models do not have associated declarative queries. This implies that you have to program the way you want to process your data. And you need a lot of expertise in order to program solutions. So you have to balance and say whether you are going to invest time on programming rather than on building the database or the opposite. Another important thing to consider is that the historical moment we're living in the historical moment we're living in, there's no standardization of neither the models nor the systems. This means that the models can change and that the systems can evolve. So the APIs can evolve and the way they implement the models can evolve too. So if you have an application and programs developed on top of these systems, the maintenance cost will be high. So that is an important thing to consider. Now, the second aspect to think about is, well, I'm happy I chose a data model, and now I'm going to collect the data and store them in according to the data model I chose. And then, of course, I want to exploit the data. Well, if I want to do this, the process is the following. It's a simple workflow. I will acquire the data somehow from sensors, from the social networks, from whatever source you want to use. And then the first thing I'm going to do is populate a database. And in order to populate the database, I might use a cleaning phase in order to kind of clean the mess of data coming from different sources. For instance, if you're using sensors, some sensors can be working in a desynchronized way. You can lose tuples, and then you have to homogenize these kind of things, or some values might be missing, and you have to decide whether you are keeping this information, whether you are keeping the fact that the values are not there, or if you are going to process the data in order to try to compute the missing values. So these kind of things are done in that process, and then eventually you will populate the database. And then you are going to use the data, which I will call that database query. And while you are querying the data, the system will kind of learn and decide which are the indexing structures that will serve to your requirements. Okay, so here you have a mess. And as far as you are using this data, the system will start organizing them. With respect to, for instance, if you're using a bunch of data a lot, what it will do, it will organize the data so that you can retrieve them quickly, and it will also replicate the data, because if one of the nodes is not available for us or in any moment, you will be able to access the data. So this is a distributed index. Distributed with respect to a physical architecture, meaning a cluster. So then this process will be the database organization. And in order to go fast, everybody knows that you need to have the data in memory. Once you have to go to this takes time, and you go less fast. So you will have to organize the data in cache. The problem with cache is that there's no durability in cache. If there's a crash, you're going to lose your data. So this will mean that the data will be replicated in several nodes, so that if there's a crash, you will still have access to the data. And if you have critical data, then at a given moment, the system will decide to store that on disk so that you will not lose important data. Once you have this, what we're going to do now is to see how are we going to go from acquisition to database population, and then how we will query the data, and finally, how will we make the data persistent if we have time. Now, in order to get the data and then put them on a database, as I said, there can be a process of cleaning, data processing. And since, as I said, the operations can be computationally expensive, we are going to present two types of approaches that can be applied under a parallel vision. So when you want to clean in a parallel model, you can do that in two ways. You can use an imperative way. This means that you have to write an imperative program. For instance, we're going to use Java, and then implement the algorithms in order to produce a clean collection, data collection. Or you can do it declaratively with a nice language that will provide operations and expressions in order to represent your transformations and then clean your data, produce your data. So what we're going to do next with Placido is that we're going to present both approaches.
I change here.
You can change, of course. So those that retrieved and prepared machines, if you have prepared machines in order to follow our exercises, you can do that. Otherwise, Placido will help you.
Okay, now I'm responsible for the more practical part of the talk. So yesterday we sent you some structure. If you configure your computer, you can follow me. If not, you can do it tomorrow or after. Okay, so I will try to show you how to hands-on these two approaches, the imperative one using Hadoop and MapReduce, and the declarative one using Pig. So during the presentation, I will try to show you how to run in a specific environment, the specific example to cleaning data and better present the data. So first of all, Donald Miner and Adam Struck in his book present a set of design patterns for MapReduce. So you can ask me, Placido, what's the difference of MapReduce design patterns and design patterns of software engineering? So this software engineer design patterns are more high level than this one. In software engineer, you have some specific model to solve some specific problem in the context. So for this model, you can implement in different languages, in Java and Python and so on. And the MapReduce design patterns are more low level. So are a specific solution for cleaning data, to join data, to get some numerical information of the structure or semi-structured data that you have. So the authors, Adam, classified in some groups. I'm showing you only 4 groups for summarization. So you have numerical information from the data, a minimum, maximum count, average, and so on, invert index, and so on. How to filter in data, how the standard filtering. Filtering considers some important keywords or values, the top 10 filtering and distinctive filtering value. Data organization, that is important because in general you have non-structured data, so you need to organize your data before cleaning or have some specific information after processing to analyze it. So, and the join one, when you have different sources or different type of values, you need to join them. So you have some type of join that you can execute to clean in data and get more specific information. So they classified the patterns in this way. So if you are not from the MapReduce domain, if you are not if you did not use it, Hadoop or MapReduce, I will try to explain how execution of MapReduce job works. So in general, each job is responsible to map the value and reduce them. So the MapReduce is a key value model. So you have some specific needs. So you have the keys and you have the values, and you need to group them. First of all, you have to separate the values and your specific key in the first part. So they split in some groups. Each group is assigned to a mapper, and each mapper has a set of key and values. And each mapper processes the group of and store the intermediate part locally. So the first part, the mapper part, is only separate and do a first cleaning organization of the values. So after that, considering the key values, you group them. So you have the groups here in mappers. So you need to reduce to get specific values and results. So it's in this way that a Hadoop job, a MapReduce job works. So Hadoop, it's a huge ecosystem. So the core of Hadoop is its file system, Hadoop file system. So it's there that you put your data. So you have all the supports and tools like Hive, like Pig HBase that executes the data that is stored in HDFS. So you can use a set of tools. You know, there is a big number if you are interested in processing data. Sometimes for the low level, it's a little bit not difficult, but you spend much time to understand how these tools works. So you need to focus in what you want to do, what of kind of data you really want. So I will present you some example. So there is some systems, some servers that you can use. If you prefer, configure your own server. Okay, there's a challenge. You can spend one day if you are lucky, or 2 or 3 or a week or a month. If you need to configure a cluster, you spend more time. But if you are interested to have on-ramp in one day system, you can download the server in a virtual machine and only use it. So you have two main systems. The first one, and most know, is Cloudera. I think most people know Cloudera. Another one that is Hortonworks. That's the system we are using to processing and analyze data. So the first part, we use some engines to process and execute the data. So I will present a really simple example in Hadoop, only to filter the data. So I have a set of data, so I need to filter them. So I have an XML data. You can use CSV, JSON, XML, and other type of data. In our example, we use XML. So it's easy. There is many APIs to process this type of data. So the problem in Hadoop is given a list of user information, compute the top 10 users based on their reputation. There is some websites like Stack Overflow and that have open data information, dump information about discussion and in comments of user. If you contribute for a specific topic, you gain reputation, and the people can trust in you in what are you saying. So there is some information about reputation. So I need to map the record to know the top 10 user considering their reputation. Okay, so how top 10 user works? It's depending on the application, it could change. In Facebook, in general, if you need to filter the data, in general, when you click in your friends, they will present you your close friends. Then they will present the last one that you have contact. In general, works like that in Facebook. When you list your friends, the first one is your close friends, in general, your family, and then you have people that you have most contact. In Twitter, it's a little bit different. They organize your followers or following, considering the time, the last one that were included as a follower or following. Okay,
so this means that Caesar was included at that. What's the date?
Last week. not for the presentation. So here we have an example. I will not present the details, only the main parts. So in Java, you can do it in the only one class. Okay. So you have the mapper. You have to extend the mapper. Okay, and the reducer. So in the mapper, you define the key values. So for us, the key and value is ID and the value of reputation. I need to know the user key ID and the value related to their reputation. So I need to know. I have an XML. I process the XML using this library to organize the data. It's semi-structured data. I need to cache the data, and then organize and define the mapper, the key, and the value. The key is the ID and value. Okay. For the reducer, I do the same. I need to extend the reducer, and then execute the reduce mapper to define the top 10, okay, and then present the values. So I will quickly try to execute.
If you want to, the code of this, I think that we didn't specify that.
This information, I think, it's an email that we sent yesterday.
I'm not sure that I did this.
So you're programming in, let me present it quickly.
And then challenges.
You can program in Eclipse. So you program your map reduce. So you extend a jar file. So to execute this jar file, you need to run it in the server, Hadoop's in the Hortonworks server. So you install your virtual machine. Here I have 4 virtual machines, and you can configure a cluster using the virtual machine. There's some tutorials on the internet to configure a Hortonworks or Cloudera cluster. So I'm using here only a local machine. So once installed, you have no need to configure the parameters and so on. It's already done for you, and you need only to execute the commands to process your data. So for Hadoop, there is no interface to process the data. You have to go to line commands and process your data. So you need to connect the server. I will connect. the server. So then I will I get the history, sorry. More. This one here. I will clean here, okay? I will need to say, it's not so good, right? I need to process the command Hadoop jar, present the jar to execute the input data and the output data. Okay, the input data it's in the server. Okay, so I will execute and I will change the URL.
What we did in our mail is we sent a jar so that you didn't have to compile, and we specified the place where you can retrieve the data.
It's all configured, but when I execute it again, it's okay. I'm sorry, the delay. And I will use this one here.
So there are three things to consider. Of course, you need your program, your compiled program. You need to specify the place where your data are. In the case of this example, this user's XML, and then you have to specify where you are going to receive the results.
Before execute, when you install your Hortonworks, this is your interface, web interface. So you have here your file browser. So you can create new folders and put your data. So our data is here, parted data analysis or input. You have some inputs here. So you use this input here, user XML. So then we execute and save the result in the server also. So I will save the result here in output data result in the folder FRBR school, right? Hope it works. Okay, I'm trying to execute, processing the job and running the job. So let's go, please. Okay, 0% mapper and reducer. The mapper phase is the more longer phase to reduce it quickly in general. Reducing. So okay, the result is the program is it's okay. So you can see the data in the file system. So output result. So you can see you have you ask for the top 10 reputation. So the first one is this one. It's a value for the reputation. The second one is you have XML rows, okay? The second one, you can structure the data, clean the data, and only present ID and reputation. But it's only a simple example. You can organize your data considering the volume of data that you have, okay? So this is Hadoop. You can use Hortonworks for Hadoop in an easier way and quickly. You install your server in Hortonworks, and then if you know to program in MapReduce for Hadoop, it's quickly. And also for the second approach that you will present. The second approach, a declarative approach, in a more higher level, it's big Latin partners. The partners are for big Latin scripts. So it's a language, a declarative language in the top of Hadoop. So you can use the infrastructure of Hadoop and its file system to execute pig scripts. Okay. So there is some similar patterns. So there is a book, more recently is 2013 or 2014 book, is a new one, that the author classified some patterns for pigs. Some of them are really similar to the MapReduce design pattern for Hadoop. So they have another classification like data ingest, data profiling, data validation, data transformation is really important. The book gives many hints to how to transform a structure to hierarchical data, aggregate data, data integration. There is some pattern for data integration. This is really, really interesting and important to process and cleaning data, and data reduction also. So this book presents a bigger number of partners and set of partners to apply to MapReduce cleaning processing. So I will present more 3 examples, simple examples, to processing data in pig. So in pig, it's not necessary to go to the line code. There is an interface. You can go if you want, but there is an interface in Hortonworks that helps you to execute pig scripts for cleaning data and have the data more quickly and in the better way of view. Okay, so now our example is to filter the test network, speed test network, given by provider in a specific city within different geographical regions. Okay.
Just to explain the context, what we have is a project we are participating in. And the idea is that you can install in your computers an application that will observe the messages that are going out when you're connected. And the objective is to try to figure out whether the internet providers are really giving what you are paying for in terms of bandwidth. So there's a project called Neubot that uses this application in order to acquire the data and build these observations. And now the objective was to, according to the region, according to the user, to see which are your connections, and in each case, which kind of bandwidth that you are receiving. And there can be 2 types of connections, so in Ethernet and normal connection, and 3G connection. And there are 2 protocols. One is BitTorrent and the other is Protocol. And
the input data is a CSV file. Yes, all this data is a CSV file, and you process the CSV, the amount of CSV file to get the information you want. The first example, I need only the providers from 2 cities, Buenos Aires and Montevideo. So there is a 1 gigabyte of data. You are using only a part of it. So if I would process 1 gigabyte, Friday you have the result. Maybe.
Anyway, in our reference, you can retrieve.
You can retrieve all the data. We only using 4 small files of 1 megabyte to process, so you can see the result more quickly. So it's really simple to program in pig. It's a script. So before define the filter command and the organization commands, you need to define where is your input data. And if you use some library to help you to process your data. So for filtering, I need to the test name. If the test name is a parameter of the CSV, name it speed test, okay? And then I filter the values considering 2 cities, if city met Montevideo and Buenos Aires, okay? So I organize the data, consider the name of the city and the name of the provider, okay? And then I if I have double information, because I will have, because you have different in timestamp. The same provider it can have information of the same provider in the same city, consider the timestamp. So I only need the name of the city and the name of provider. Because of that, I distinct the result. Okay. So in peak, I'm sorry. Okay, in peak we have this interface. You have your script here. So the code that I just showed is this one here. Before I need to structure the data. So I need to define the inputs data, and then using pig storage, I organize the data. So I need to organize and structure data before execute. So it's really simple, and I execute.
For those that are acquainted to SQL, the idea is to have every operation related to data processing is going to be associated to an operator, as the way we use SQL, and the set of the line of operations are related to an imperative program.
Yes.
So you have the combination of the declarativeness of an SQL-like expression and divided in several operations that are executed either sequentially or in parallel.
So I will come back. I will leave executing, in cleaning and processing the data. And I will, after 4 minutes or 5 minutes, I will come back to show you the result. So now, we presented simple example only to filter data. So sometimes you need to do more complex cleaning, join information, or have more specific values. So in the Hadoop ecosystem, pig is here, and high-level interface. Pig is executed in the top of Hadoop. So because of that, is less performatic. So you have the result more quickly using Hadoop directly, because you are not a script language to transform in the Hadoop execution. So it's easier to use pig. You learn quickly pig, and you can process data more in an easier way. But in some case, this is less performatic. So you are doing some comparison of patterns, considering pig and Hadoop. You have some initial results that use Hadoop directly. For some patterns, it's better, depending on the context, than using pig. Even if pig, it's easier to use. Okay. So in the context of Hortonworks, you have here the Hadoop file system. Pig is here. You have other ones, other tool and other approach that you can use. So pig script is here in the top of Hortonworks. Okay. So this is the example that I'll just show you. Okay. The example is running. So now, as Genoveva said in the middle of the presentation, we need to organize the data. You need to have more precise information considering the different type of data if you need integrated data. So for this, you can use pig script for execute more complex data, more processed database querying. So you present another example. So if you need to the highest number of tests, considering the evolution of download speed along the time, consider a provider, you need to filter the data from provider and cities, and then organize the results considering the time and the download speed, and enumerate the countries in which the tests were done. So Uruguay and Argentina, Brazil. If you need the volume of downloads and speed tests that were done in considering the providers, you can clean the data to get this information. So we have a more complex script. So I will not detail them, okay? This script is to get the information about the one specific provider in one specific city, the evolution of downloads, the speed tests used during a day, during a month. So you can define this in your script, and you have the result quickly. So you can do simple filtering tests, but in general, for data analysis or data cleaning, you need to do more complex execution. I'm not talking about join. It's only filtering. Join is is worse considering performance, because you have different type of data of different providers. If you need, you have to integrate this data. Even if you have the same provider, so to join the data, it will be more time consuming. Okay, so it's here. It's an example of considering the timestamp of the number of downloads.
This is the result of the query.
The result of the query, formatted, not in P, but in a specific tool. Okay, this work was done by Javier, Genoveva, and I. So you can present the results considering the time stamp for the download. So I will put to execute that script. I don't know if the first one has finished. Yes, it's finished. It's green here. It's only 2 providers. Oh, one is. I'm sorry. What happens? I'm almost there. No.
Maybe we're going to skip
to yours.
Yeah.
Maybe. No. Yes.
It's taking the.
I'm not present the example. No.
I think that we have to conclude.
Yes, I will only present the choice. Okay. No?
Are you sure that you're using the good?
Yes, the good one. Yes, is there?
Yes. Yes.
So I present the choice. So to finish, I will present a join example very quickly. So we need the first example we used was considering the user reputation and the local that he did his comments. So to remember you how a join works, you have 2 informations in 2 different tables. So user and post, considering the users. So you have the user ID.
Attention, we're not referring to relational tables. It's just tuples.
So only informations, not relational. Okay, and the location, and then you have user ID, the post ID, and the text comment, considering that user. So the join or the inner join it's the intersection considering the users and the posts. And for SQL query, the simple one, select from a specific table, then you can join the value, consider another table of information. In the result, it's like that. So you have the user ID, reputation, location, the user ID also, its intersection, and in the post syntax. So for pig, you have two different files for the same source, or from different source. You have information about the user in the XML and information about comments in another XML. So we need to load the input data, structure the data for both files. Then for each row, format the data. And once you have the data formatted, you can join the values. So the problem that Bernadette said in his talk, considering structured and non-structured data, it's really difficult in our case also, because you spend time to format the data, to structure the data before cleaning or have more specific results. So considering, I will try to, then you store the data, right? You have the result, you need to store the data, you store the data. So I will present each part of a pig script. So we have here, I'm loading the comment. So I load the comment, I load the user also. Then I need to format the data and say what is important for me here. This information are important. I'm formatting the data from this file and formatting the data from the other one. So it's this two one here. And then apply the join. In pig, it's really simple. Use a join. It's only join. Comments by user ID, comments by user ID, and user by ID. It's simple. So, but before you have to structure the data. And then you dump the result or store in somewhere, okay? And the result is like that, okay? So you have the comment information, the post information, the that create information, the user ID information, it's the same, you can see, because it's the join information that are important for me, then the user reputation, and then the user data creation. So you can clean your data, take information of XML data, and cleaning the data for your needs, okay? So we have no time to execute. You can execute the pig script after, but pig and Hadoop are two interesting tools that you could clean the data and present your data in a human understandable way, or computed also in a way really quickly if you decide to use a management system like Hortonworks or even Cloudera. So Genoveva will conclude this information.
So Hurricane Placido didn't start for those that wanted to execute. If you're interested in executing the exercises, this is just kind of publicity. You can go to our Big Data Fest site. There you can find three possibilities. Either you have the incomplete Java code where you have to program the map and the reduce functions for some of the exercise, and compile them and then execute them with the data we provide. Or you can just see how it works and retrieve the executable jar and see what happens with some of the exercise we are providing there. If you're interested in other material, there's also a lot of material in there. And if you have questions, you can, of course, contact us. The idea of the fest was to have a kind of hackathon exercise where there are a set of challenges to be done by groups of people, either to retrieve and create data collections, because as Bernadette said today, the problem today is to have data. So everybody is talking about data, but few have real important data collections to play with. So our idea with the Big Data Fest was that people were intended to go and retrieve data and build collections, clean collections that could eventually be used for other exercises. So there you can find some of the results. The fest is going on, it will finish next month, and we will publish the data collections that have been retrieved. They concern drones, for instance. So the drone is running and you get the logs. There's things about traffic, about behavior of people in cities, in Montevideo particularly. So these kind of things you can retrieve. And then, of course, the implemented and non-implemented challenges if you want to test. Of course, I'm not going to go through the other parts because we are have run out of time. So just to say that there are two important remaining operations to be considered. So once you have built the collection, that you have filtered and you have nice clean data collections, you can then go through a manipulation phase. What is important to consider with respect to data collections today is that data, as big data is related to velocity, new data are coming. And the big challenge with respect to these data collections is to curate the data collection. So you need somebody that is adding new data, that is maintaining the collection, that is storing new data in other storages in order that people can use that. So this is a very important challenge. For instance, here in France, there has been lately a call from the CNRS intended to have data engineers and data scientists just caring about the data collection, which is a whole work besides the fact that others can manipulate and can exploit the data. So just to say that, to make clear that it's not an easy task to have these collections ready to use. And then, in order to conclude, 2 words about, I'm just looking for the good slide. So there are 2 important also things to consider. As you have seen, there are a lot of models, there are a lot of systems that can be used in order to deal with your data. The question is, which one are you going to use finally? As I said, the problem is that there's no standardization. So you have a lot of systems, and then what do you do? What is important to say is that despite the absence of standardization, you can count on benchmarks today. So, for instance, there's a Yahoo benchmark, and then, well, that's again a little bit of publicity. We have extended the Yahoo benchmark for NoSQL systems. The idea is that you have your data collection, you pick a sample of your data, and you provide that to the benchmark. And the benchmark is receives the data and is connected to several installations of different, most prominent NoSQL systems. And what it does is it tests how your data will behave with respect to the different implementations. And what it returns is what is, for every model of the data store that are connected to the benchmark, how will your data management perform with respect to several quality values? Of course, there's performance, there's availability, there's fault tolerance, which are the first three important properties to characterize NoSQL systems. But there are also more like qualitative ones, for instance, whether the system is changing API a lot. Because if it's changing APIs a lot, this will impact your data maintenance, okay? So you have results like graphic results on the behavior of the systems, so that you can make a decision on which one you will use. It is important to know that normally there's no one system that you are going to use. You are going to need several systems depending on the type of data you are using. So you are going to combine several NoSQL stores in what we call the polyglot persistence approach. Okay, so you will have to deal with this kind of challenge. And last but not least, another important aspect to consider is, I'm just looking, sorry for that. Yes. To make the decision, what is important to keep in mind is that concerning the management of data in NoSQL approaches, you have to deal with three concepts. This is intended to represent what we call the CAP model, the CAP theorem, and it says that there are three important elements to consider related to NoSQL: availability, fault tolerance, and consistency. And the idea is that you cannot have all of them. If you choose availability and fault tolerance, you have an impact on consistency and so on. In general, NoSQL systems are privileging fault tolerance and availability, and there's less consistency involved. Okay, so if you want consistency, this doesn't mean that you won't have consistency in your application. It only means that you will have to program it. Okay. So these are the three elements that can guide you in order to choose a NoSQL approach. And that's with these words I will conclude. It's nice to conclude with the CAP model. Again, just to not to open the room for questions, if you are interested in using the benchmark, our benchmark is available online, so you can contact us. It's in JIT, and it uses, as I said, the YSCB benchmark of Yahoo. And if you want to contribute on that, we are also happy to collaborate and go further on benchmarking with NoSQL. So thank you very much. And I think it's time for coffee. If you have questions, we can have questions around coffee. Thank you.
We could take the photo.
No, oh yes. We're going to take a photo
Of everyone here.
And after coffee break, oh yes, after coffee break, there's a visit to the Fab Lab. We're going to divide the group into no? Or everybody can come?
Yes.
Okay, so no division. So after coffee break, we will go together to the Fab Lab to have a visit.
You take one to the photo?
I take one.
The Brazil.
I take the Brazilian.
You take the France.
And I am in blue.
Daniel, Marquinhos pode tirar uma foto do lado. Você aparecer aqui. Sim, deixa eu só deixar aqui descarregar.
Sorry?
Everyone for the photo. It was cool?
Yes. And where are we taking the photo?
Here.
Ah, here? Okay.
Here. And there's for the Marquinhos pode tirar foto da gente.
Certo.
Assim. Almost.
Almost there.
Esse aqui não tem muito remoto, não.
Tarán. Yellow. Nos hace falta amarillo y ya.
Todos. Não acredito.
¿Del baño, no?
Não, banheiro. Vai ver lá se ela tá.
Cada com ovinho de Páscoa.
Ovinho de Páscoa pode ser também.
Sí.
Xavier.
Yes, why don't you put the salt, no?
You need to put your password here.
My
No.
what?
Ah, pero es rojo.
No.
Ese dice.
I that's a password, I think.
I'll open here.
If I ask my students to do something and I have a password, they cannot. Está abierta. Abre Safari. Ah,
Safari.
sí, acá está sí, como Chrome, Safari. Y acá, por aquí está. Pero,
Nope, not okay. Not okay.
la ciudad
Okay.
es. No está muy bonita, pero no creo que se vea.
I need you.
Yes.
Squeeze.
Slim and young.
Like this.
Okay, that's it. Say cheese.
Again.
Claude is missing.
Okay.
Wait,
And now I need the volume.
wait.
Wait a minute.
Claude is
Claudia,
still missing.
¿se puede ver en el Claudia?
Can I be here?
Sí. Ven, Claudia. Frente a...
No, it's okay.
Okay. Thank you.
Thank you.
Todos lindos y jóvenes.
Todos jóvenes, lindos, flaquitos.
I want to picture. Just take a picture.
Você anda com a bandeira na mochila?
¿Qué pasó?
Oi?
¿Se fue la red?
Oh, yo soy.
Ay, lástima.
¿Cuál es? Este.
Una. Sí, eso. Una, dos, tres.
Thank you. ¡Qué bandera!
Você manda, né?
Tá.
Depois.
A gente fica no meio? Você é brasileira hoje.
Sim. Tá direito?
Tá. Muda a foto aqui com a bandeira da outra.
Oye, y me decías que, que solo México tenía bandera. No.
Alexandre. Ah, para Alexandre lá.
Você?
Lá também é Brasil. Você é brasileiro? Você é brasileiro?
Não fica ninguém.
De plástico. Estoy con ese del lente.
fun.
Thank you.
Thank you. Thank you. Muito boa a ideia das bandeirinhas.
Deixa aqui.
A minha foto ficou muito boa,
Deixa eu ver,
porque
vamos passar
fica a bandeirinha e eu...
I'm going to close the
Aqui eu vou
room
trabalhar com
before.
detalhes no artigo.
Tá.
Acho que a gente não se vê depois, porque aí
Mas vamos manter o contato.
Vamos, eu tô organizando ainda como é que eu vou fazer pra essa coisa da coleção de sinais, mas eu acho que é uma super oportunidade a gente falar sobre isso.
Eu estou coletando. Eu tô coletando os dados abertos do Brasil. Mas uma questão interessante o que eu preciso para vocês são os dados de GPS. Eu vou ver lá o que a gente consegue. Viu? Esses dados não quero, o que a gente consegue.
Bem,
Muito bom encontrar.
muito bom.
Muito bom rever, viu? Parabéns.
Bom saber que a gente está convergindo no campo Placido.
En fait, l'invitation pour l'accès.
C'est ça.
Fez um mestrado.
O Placido.
Placido, ele é tudo Placido agora.
Ici ou pas?
Vous pouvez revenir ici. Donc, après la visite, je peux ouvrir.
Ah, non, mais...
OK.
Eu vou pegar só o teu.
Entendi. Enfin, je pense qu'on va aller parce que l'évidence qui sont pour les preuves qui sont
Foi praticamente no meu primeiro ano a ser, no último
Mas eu vou trocar de coisa. Eu vou lidar com o mapa.
Não perder.
Aí,
Deixa eu tá aí. Deixa eu puxar, tá aí. Agora eu vou dar o...
Quelle adresse tu utilises pour OneDrive? Gmail.
Gmail.
aí você sente o choque da área.
Tiago.
Quando vocês vão terminar o doutorado, eles chamam para mim. É bom, mas assim,
Did you took? Did you take?
Yep.
Oh, you have one. Let's go. So, you got break?
Yes, I'm just sending something.
Isso aqui tem alguma coisa errada.
Est-ce que tu peux vérifier si tu...
Si je peux y accéder?
Ouais. Bah, si déjà tu as reçu l'invitation.
Mon invitation, oui. Je vais vérifier pour ces changements que je crée déjà ici.
Je pense que j'ai les accès aussi. Par contre, c'est normal que les slides soient en 16/9.
Si.
Ok, cool. Ça marche.
Donc, l'idée, c'est que, alors, qu'est-ce qu'on avait dit? Donc, c'est à partir euh, hmm,
Il y a 25.
si, donc, voilà, slide 25, bon, 24, c'est ce que on a fait sur le papier, quoi. Donc, en fait, moi, je peux m'arrêter, bah, c'est comme vous voulez, je peux m'arrêter au slide 12, parce qu'à partir de 12, c'est l'histoire des taxis. Ou je peux présenter aussi les taxis et donc vous démarrez à partir du slide 20, problem state.
Ok.
Moi, je pense que, bah, je ne sais pas comment tu te sens. On peut démarrer à partir de, bah, vous pouvez démarrer à partir du slide 20. Je peux lui donner un texte, surtout pour la dernière partie qui est ongoing work, et toi tu présentes, bah, ça c'est ce qu'on a écrit sur le papier, donc le 24, et tout ça.
Perdón, yo censuro un instant.
Oui.
No, no, c'est la vidéo. Me los llevo al Fab Lab una vez que ya vea
Sí.
que están tranquilos. No sé si llevármelos en dos grupos, los tendría que dejar acá,
No,
pero ya no
porque
cabe
ese-
todo el mundo. No cabe todo el mundo.
Pero que se esperen allá, porque si no se pierde.
Sí. Entonces me llevo a todo el mundo y
Ajá.
así que no
Ajá, y
molesta.
ya me quedo yo con Bernadette y Martín.
Y ya después que se vayan ellos a cada quien a su casa.
Bueno.
Ok. Tú te quedas aquí. Ok. Vale.
Je vais me faire connecter à moi. Là, c'est bon, j'y ai accès, donc je pourrais jeter un coup d'œil ce soir. Faudrait que je regarde comment configurer PowerPoint pour qu'il projette en 16/9.
Bah, on va utiliser les mêmes PowerPoint. On va pas jongler.
Non, c'est sûr. Mais, de toute façon, mais,
Tu sais comment faire?
non,
C'est super simple.
J'imagine que c'est dans les options. Je sais pas.
Tu vas sur mise en page. Mise en page. Tu vas ici.
Ouais.
Et tu fais ça.
Ok.
Ouais.
Parce que en plus, je trouvais ça très souvent gênant d'avoir la moitié de mon écran qui était coupé quand je faisais des présentations. Donc c'est pratique pour les prochaines fois.
Oui. Ok.
Ok, ça marche.
Okay. Si tu as des questions, tu me dis. Hein?
Oui.
N'essaye pas de tout résoudre toi-même.
Et il faut que je finisse, il faut que je fasse l'article quand même. Il faut que je jette un coup d'œil. Est-ce qu'ils n'ont pas mis à jour les dates ou pas?
Les dates, ok. Ouais. Non, ça marche pas.
Non, je disais comment est-ce que le monde fonctionnait avant les smartphones.
Ah oui, c'est vrai que ça change la vie.
Je vais pas changer. Ok, on va faire descendre prendre un café.
Ok.
It's okay. Mas também.
E lá eles estão fazendo uma link, inclusive, assim, ó, tem gente que contribuiu para a construção do curso que está sendo descredenciada, que às vezes se diz assim, pô,
Não, pois
vamos respeitar um pouco a história também.
Não, é o caso, sei lá, do Bigonha, nas Minas.
Mas tu deve conhecer pelo menos o nome. Ali ele estava.
Sim,
Pois ela está para ser descredenciada. E olha quem que a Viane é, né? Assim, ó,
pois
ela
é.
deve muito a ela, mas como ela começou até a se dedicar na parte de informática e educação, aí o tipo de publicação que ela tem lá, que tem um monte,
não conta para o poli da ciência da computação.
E daí ela começou a perder lá os índices bibliométricos, ela tá com a cabeça com a cabeça na guilhotina. E assim, ó, para mim, o maior exemplo de uma certa forma dos negócios que às vezes
sacanagem institucional, né?
Porque assim, ó, tem que manter uma
aqui na frente,
né?
Então, será?
Manter uma pessoa como ela, porque até pelos recursos que ela tem, né?
Veja isso. Assim,
eu tenho respeito à pessoa, à história que ela construiu tudo negócio. Eu particularmente acho assim.
Tem umas pessoas claves, tem as pessoas chaves que assim, não dá para ter.
E ela é uma coisa assim que.
Mas, enfim. Mas é isso, tá? Tá, bom, deixa eu trabalhar com essa pessoa aqui.
Já que não tem mais apresentação, então vamos embora. O Fábio lá já visitei bastante de dia lá com esse.
Aí amanhã em sexta tem.
Amanhã às 9 eu vou aproveitar e vou fazer um negocinho que a Genoveva estava falando.
Eu vou preparar também hoje de noite.
Vai de Porto Alegre.
Beleza.
Mas então tá, um bom trabalho.
Obrigado. Eu vou pegar outro desse. Ninguém quer, eu vou pegar.
Eu vou levar um para minha sobrinha.
Eu vou levar um para... Porque assim, eu vou visitar aqueles meus... Eu tenho um amigo, o meu único amigo de infância mora em Paris, né?
É mesmo?
Que a gente é feito irmão mesmo, não é só amigo, não. É mais do que amigo, bem mais. E ele tem 3 filhos, certo? Ele casou com a francesa, tá aqui. E... Eu vou levar um ovinho para cá.
Você vai daqui para Paris?
Eu vou para Paris, vou passar um dia, só um dia em Paris, porque... Mas eu visito ele bastante. Porque tem um menino mais velho dele, que tem 12 anos, que vai tocar no restaurante.
Que legal.
Ele toca a flauta. E a professora dele...
Que bonitinho.
Ela está organizando uma soirée.
Legal.
Como ça. Ok.
Donc.
Eu vou pegar os... Puxa. Deixa eu vou o cara na silla
Sí,
também.
una silla, claro. Te mandei unos papers. Sí.
Muito obrigada.
Sim.
Eu não consegui ver,
No, me imagino.
mas eu vou ver com calma.
Porque lo que de la presentación que hiciste, nosotros estamos abordando problemas de integración de datos, que es un trabajo que hacemos con Martín y otras colegas de Lyon. E...
Em qual eu toco de ouvir na igreja. Mas enfim.
La idea es...
Pode pegar.
A ver.
Tá transmitindo.